Hello everyone. Right, I've got the switch for this part one of the multimeter low ohms adapter, and it is an adapter. What it actually is a current generator. It generates a current in two ranges. It generates a current at 10 milliamps, and it creates a current at 100 milliamps. Like I said about designing this adapter and measuring low ohms, the more current you put through it, the easier it is to measure the actual voltage, and of course you have to remember that the only thing that we can measure is voltage, and the more accurate we can measure the voltage, the more accurately we can calculate the resistance. I do hope that made sense. Oh, and with this video it might get long, I don't know, so you know where the fast forward is. You can just skip through bits if you want, but I just want to go over. Now I've got the switch, which is here. I've done the circuit board. Let's just have a look at the circuit. So I've added some extras. What I find with making PCBs is you don't design it with the minimum, just what you need. Add things that you might think, oh, maybe I can do this in a later project, and maybe if I add this and that, you know. The time to do it is add them now, and it gives you the option not to put them on if you don't want to. So the way I've designed this is it runs off 3.3 volts. Well, it's going to run off two one-cell batteries, which is going to give you 3 volts, but the reason I've said 3.3 is because of there's going to be a part 2 which is going to be a lot better than this, and it's going to measure the low ohmage really accurate. Well, in theory it should really, it'll be equivalent to a bench tester, you know, the accuracy. Anyways, that's part 2. So what I've done here, I've added this here, these headers pins, where the battery's going to go. I'll show you that in a minute. You don't have to fit them, it's an option. And also, when we're testing devices, we need to press this button to test. It might be that you want to leave it on permanently. So what I've done is I've added another header here, and we can put a jumper across this, and basically it just shorts this button out, and it keeps it on all the time, so you can just keep swapping out components to test. It's an option, you don't need to take it, you can leave it off. So that's what I've done to this. So if we look at the actual PCB, you can see I've designed a PCB, and it's a multimeter low ohms adapter, and you may be wondering why we've only got 2 probes. I know you're saying that you need a Kelvin meter to test low ohms accurately, and you do. You need 2 sets of probes, but what I try to explain is this is an adapter. So, and you can see that there's only 1 set of probes here, and you think, well, where's the other one? Well, the other set is on your meter. Like I said, this is an adapter. It's an add-on for a meter you already have. So there's only the 1 set of probes on this, because all this is doing is feeding current. And I've done a picture. Let me get the picture. There we go. Here's the picture. So this adapter here, this is what this is this bit here. This bit is just this adapter, and you've got your two leads, which will be getting connected to the device under test, and you have your meter, and your meter has two leads, the device under test, and now you can see that there's actually 4 probes. So there's 2 sets of leads which you have with a Kelvin probes, and now you know where those probes are coming from. One is actually measuring a voltage, and one is actually generating a current, and it's the one that's generating the current is the one that we've just made. So all this does is put a current through the device under test, and we've got a choice. We've got either 10 milliamps or we've got 100 milliamps. And this is calibrated by these 2 tunable potentiometers. So you get I think I went over how to do this. You put a device under test, say a 1 ohm resistor that you know that is 1 ohm, or you know what it actually the exact value of that resistor is, and then you can calibrate it by calibrating this to the millivolts that to 100 millivolts, and then you know that 100 millivolts equals 1 ohm. Or if you then go to the 10 ohm watt version, which is the 10 milliamps. Oh, sorry. I wonder. I think I should. I'll tell you what I'll do. Also, yeah, the 100 is the 1 ohm, and the 10 milliamp is for the 10 ohm range. I think I'll better write them in as well, because you might get them the wrong way around. So let's put a bit of silk screen on there. But basically that's what it is. So now you can see that we're actually using a set of Kelvin probes. One is to the multimeter that you already have, which is measuring millivolts, and one is to the adapter that we're making here. So at the device under test, you've got like 4 probes. So I hope that made that clear. And the reason for the adapter is that your voltmeter can't supply the current that we want for the test. Well, not all meters do. The more modern meters, the ones that have got microcontrollers inside them, these days, the newer ones, they can do this, because basically with a microcontroller, with a microcontroller you can do what I'm going to do in part 2. It'll come clear in part 2. So anyways, but this is just the adapter bit. This is just the current generator bit, which you can add to a meter to actually measure low ohms value. Anyway, I think I'm going round in circles there, but you know me, I tend to ramble on. So here it is. Oh right, yes. So let's just add some silk screens on there as well. Like, so if we go to silk screen, and what we'll do is I'll just copy that font, and paste another one here. So we'll go there, and I'll just copy that one and paste that one there, and we'll edit that. So this at 100 milliamps, you will calibrate at. So let's put cal and at. Oh, let's use that. So let's have a look at this. We'll do that. Cal at 1 ohm. Now, do we have the ohm thing? Oh, I don't know. I forgot how to spell ohm. Oh, right, I got that wrong. Oh, there we go. Let's just move that. There, see what that looks like. Oh, yeah, we could do with the little thing, can't we? 1 minute. Well, actually, 1 minute. I'll just bring me character map up. Just give me a more. There we go. I can never remember where it is. What we're using, well, aerial will do. Basically, what I want to do, I can never remember the actual shortcut for it. So we're looking for ohms in here somewhere. Well, I can't reduce it. Oh, where the hell is it? Right, I think it's in the extended thing, isn't it? Let's have a look at another one. Let's go for times New Roman. That must have it. Where's T times? I can probably see it better here. No, I can't. It's not here, is it? It's not in the. This is just a lower sheet. This. All right, just give me a minute. Oh, hang on. What's this? Advanced view. What's that? Is there a search? No, Unicode. Bollocks. Anyway, right. 1 minute. I had to find something that I used the ohm symbol in. So. Let's get rid of the at and just have cal ohms. Right, let's see what that looks like. Cal 1 ohm. Right, yeah, there we go. That's better, isn't it? And it's actually written it, so I'll just copy that text and we'll just change that into here. And this is used a 10 ohm resistor here. So yeah, that makes it a bit clearer, doesn't it? So we've got our switch for our range, that's our 10 milliamp and that's 100 milliamp, and we use a calibrate with a 1 ohm resistor when it's in this position, and cal with a 10 ohm resistor when it's in that position. So basically you just put, if we're doing it in the 10 ohm, you stick a 10 ohm between these two probes, and then you tweak this one. I've put this all on one side, so you'll tweak this VR10. That's why I've called it VR10, because it's the 10 ohm, and I call this VR1 because it's the 1 ohm. So you calibrate that you turn this little screw here until it reads with a 10 ohm resistor in. You calibrate this until your meter reads 100 milliamps, and when you're in this position here, you stick a 1 ohm resistor in there, and you tweak this thing until your meter reads 100 milliamps, and that makes the sums. You can do the maths in your head then by just moving the decimal point along. Right, so yeah, I've got that. So yeah, what was I talking about? Yes, the options. Right, so I've put these two extra pins in there. Let's have a look and see what it looks like. So I'll just make that small and make that big, and then we can see. So this is what it's going to look like. So we, like I say, you press this button to test, because basically that just connects the battery. What I've done is I've used one. I've drawn another thing, battery holder. What I'm going to do is have this loose inside a box. So I'm going to put this on top of a box, and this will be loose inside. And at the moment, you can just solder onto these tabs with these two wires. But what I've done is I've put this little pin here, that pin header here, so you can actually put a connector on end of these two wires and then plug into that pin header. This pin header, right, this one is if you want to keep it on all the time, just like an on-off switch. Stick a header across there, and basically you bypass this switch and it stays on all the time. Now it's an option, so what I would do is just leave it off if you're just going to use this button. But if you want the option of actually connecting it on, keeping it on all the time, just put a header across that pins, keeping it simple. There's our switch and our new silk screen that we've added. So this puts it into the two different modes, and these are your calibration potentiometers. Right. Yes, so this one's got a header on, and as I did before, let's make that smaller. Now, before, what I did was I showed you how to create these components for these for these things here, and this made a footprint. But what KiCAD can do is, like I said, this is a standard footprint, and so you don't really want to alter it. It's a pin header thing. But if you want to show say like a jumper across there, we can draw that in, and the reason I want to draw it in is because I want it to look, as I say, exactly as what we're going to make, because I want to do a box for it, and I want to make sure that it fits the box and looks alright on a box, which is what we're going to do in this video, is actually make a box for it. So I want that to look like it's got a header on. So what we can do is, in here, if we get the properties of this jumper here, that's not the wrong one, that's the wrong one, let's zoom in, there we go. We get the properties. Oh, it's already on the properties there. So actually, I think I've gone too far ahead. Let's just get the properties, which is yes, that basically, right? And what we want to do is actually edit this footprint. You can either edit the main library footprint, that's the library where all your footprints are, but I don't want to change that. I just want to change it in this project. So what we can do is actually edit in just this project. So if we go to edit footprint here, and it comes up and it shows you that you're only editing this footprint in this project file. It's not going to do your main library of components. And so if we get the properties up for that, which shows us this header here, basically, what we can do is we can go into our, well, I can go into my library of models that I've drawn, and I've actually drawn a header. So what I can do is I just go to this file, and there's my header that I've drawn. This is with all the other components that I've made in FreeCAD, and I've exported and put into the folder. So there's my header. So go OK with that. That adds that, and then what we can do is we can alter the rotation. That's that. Let's just make it a bit higher. That's that. So that's going to sit on there like that, and we just want to move it across. Which, where's my calculator? What we got? So the pin distance is 2.54. Cancel, and I bet it is 2.54 divided by 2. I bet it's 1.27. Let's try that. Which way are we going? That one? That one. So minus 1.27 a bit. Yeah, there we go. So that looks alright, doesn't it? So we've got a header on there. We go OK with that, and then we save it into our project. And what we need to do now is, if we look at our project, what it actually looks like, we can see that we've got the header on there, basically. And so we're looking at what we're actually going to make now. Right, so I want to make a box. Yep, I want to make a box for this to go on. I've got my holes in there. I've made them 2 mil diameter because they're going to be. I've got some self tappers which are M1.7, and they go nicely in there. What I use, and so let's make a box for this. To do this, we're going to use KiCAD, and so. Now that I know everything looks good, hunky-dory, and I've got all my everything done on my circuit, I've even filled in the extras, so like I say, so I've put everything on the underside, all the traces on the underside, but I've left the components on top because I like to see them, basically. Yeah, this is a gadget for the nerds. No, and like I said, I like to fill in the copper between. So that's where the copper filled in, and it's the top and bottom. So where was we? Oh right, yeah. So we've done that, and obviously with all components. Yeah. So after, whenever you do a PCB, you should always check it. So we have design rules, and we do run a design rule check, and just make sure nothing's wrong. I've got a warning there, so I've got footprint battery holder does not match the copy in the library. Yes, I know that, because what I've done is I've actually altered it. So if we look at our battery, let's look on the back side. So look at my filters down here. Let's have a look at the back layers. There, can you see? Oh, let's bring that silk screen to the top. So you can see my battery silk screen, where my battery thing is going to go. I'm going to leave it loose, but I've left space for it there, so you could actually glue it to the back of this PCB if you want. But what I've done is I've edited some of the silk screen, so it doesn't come over the top of this, and it doesn't come over the top of this copper here, basically. I don't want it to when they make the PCB, we don't want silk screen over the bits where we're going to solder, do we? So that's why it's been edited, and it's telling me this warning that it's not an exact copy of what is actually in the library. So what we can do is right click and exclude that violation, because we know about it now. And doing that, it reminds me that I don't have to remember every time we do a check. And so it's all green, so we know that's okay. Close, and what we can do is I've got this add in here, PCBWay, and if I wanted to get that printed, I would just click that button, and it would go to the site and upload all the relevant files needed to have it made. It's just one click, that's all it is. Tell you what. Let me just show you. I'm not going to order this one because I'm going to do a part 2. So if I bring my Explorer in here, actually I'll minimize, make this smaller so we can see what happens. So basically, bring the my Internet Explorer. Clicking this would bring this open this. Well, I tell you what, let's close this and see if it opens it, shall we? So let's close my Internet Explorer. Oh, hang about, I've got something downloading. What have I got? Close browser. No, I know what that was. Yeah, let's just click the PCBWay button. There we go, you see, it's opened up my Explorer and it's uploaded my files. And that's it. There's options I can do and stuff, but basically I don't want it in the United States, I'm in the UK. So what I would do is I'd change this. I'd actually log in anyway. But where are we? United Kingdom, and I'd probably pick one of these cheaper ones here. I'd go for the cheapest, apply that, and then what I would do also is here pieces. I would just choose 10 instead. The value has not changed, it's still $5. And like I say, we're shipping, it's there, $9 for 10, so it's just over $1 per PCB. You can't beat it, can you? I also like to make mine blue as well, so I usually go blue and white. Yeah, but it's just still the same price. No issues. Okay, save it to card, give it all your details, and there you're done. So that's it. That's as simple as that. It was just one button. That PCBWay button. It's an add-in that you add to KiCAD, but it just does everything for you. Right. So what we're doing actually is now I've done that and we've saved it. I can close that basically. What we can do now, there's the switch that I drew. We don't need that anymore. Close that. So now we're in FreeCAD. So all you have to do is remember. Hang on, let me just minimize that. Let's just close that as well. And KiCAD. So this is the main KiCAD thing. We've got this little button which will tell us where we are. So if I do that, it'll open up the Explorer. Which is where our project is, and you can see that we've got our KiCAD files in here. You can see that zip file it created. That zip file there is basically all the Gerber files and everything that it needed, PCB needed. This is what it created and uploaded to PCBWay, which is all the Gerber stuff. It has the bill of materials and it has the position file and everything. So that's that. But I just need to know where everything is. So basically, I'll just copy this this path. Okay, so I'll just copy that path. That's where it is. So minimize that. So what we want to do is open up our project. And what our project I want to open up is the one where our Ohms adapter is. So we go there and we can see that this is the adapter KiCAD PCB, and I'll click that and bingo, in KiCAD it just imports what I've done in KiCAD. So now we're in FreeCAD. Get rid of all that crap. So in FreeCAD there is the circuit board and the components and everything. So now I know what to make my box around. So what I'm going to do, this is all the components. We just need to get them all minimized. We don't need all that listed. So now we've got that, we can start making our box that we're going to 3D print out of on our 3D printer. So what we do is we create a part, and that part needs a body, and that, to start off with, we need a sketch to draw the shape of the body, and we're going to use the one in plan, basic one in plan. So I'll click that one. And that's where it's going to sit. I thought I'd got that in the frigging middle. I mustn't have. Well, that was supposed to be in the middle. I'll have to just work out how far out it is. So, right, so to view on our view plane actually is, at the moment, it's on top of the thing, but we're going to move this view plane down here, so it's the base. But I'm just going to draw something in there just to give us a bit of a something that we can actually see. So let's just do a box. And I also want I like to do it this way. This is the way I like to do things. So what I want to do is centralize that. So it's just so I can make everything symmetrical about the center, basically. So what we're going to do is we're going to put some radiuses on the corners. These will match the ones I've put on the PCB. So got them radiuses, and because I've got my construction one in the middle there, what I'm going to do is just make all these touch that. What I'll have to do is get rid of that constraint because it'll affect things. C, and then I'll just press in C on my keyboard. to join things up, and I don't like these at the moment. Yeah, you may have seen me get rid of these confusion things. If I want them, I'd put them in. It's a pity I want to. I don't know. Maybe there's just something in the settings that allows me to do that. And what I did is I made these radiuses 3 mil. So let's make that 3 mil as well. Like. Okay, and obviously our box is too big, but the trouble is I've made that offset, and I didn't really mean to. I could show you how to centralize it, but I'm not going to. Not in this one. Maybe another episode if somebody wants to ask. And also what I want to do is we're going to have some holes, so let's put some holes in. So each corner is going to have a hole. There we go. So if we select all them walls, and I know what size they need to be to fit my M 1.7 mil 12 taps, which is 0.6 mil radius. So that's for my little self taps to go into. So let's just get this board in the right place. Well, yeah, we'll move the board. I'll keep the box where it is because that's what we're making in this PCB. Not in this 3D model. So let's just move that down. Let's get that central. So it's the Y axis. Right, 1, 2, 3, 4. So go back up 1, 2. That should be about central. That. So if we go back to our sketch, we can now position these over them holes there like that. And we know what that dimension is. It is 74. And I know what the dimension is. It is 44. There, so we've got that made now. So that's how we know it's going to be the same size as a PCB because we've imported the PCB. So let's just close that. And what I need to do now is to position that. That sketch is going to be at the underside of this because we're making a box for this to fit in. So let me just move this up now. So let's just move that up out of the way. So we can see our sketch, that white line there. Let's just zoom in a bit. I thought I forgot to press unpause a minute then. Right, so we're going up. So that wants to be above that white line, and we're just above there. And I want that box to have like maybe a 2 mil thick base. So let's go 2 more mil. So I've pressed the wrong one there. Let's just go up 2 more mil. 1, 2. Right, so we know that when we make this into a box, this is all going to fit inside. So let's just make that into a box, and we need it to go all the way up to that's going to be a half, is that, isn't it? No, it's going to be 0.4 because this is 1.6. So it'll actually be 0.4. So that comes underneath there, right? So basically, we've made our box. What have I done? I've messed something up somewhere. What was it? This one? Yeah. There we go. Right, so that's going to be our box. But if we look at our box is solid, isn't it? So we need to take something out of that. So in our body, we need to do another sketch. So we'll do another sketch in plan, in base, and if we look down on it, so if our box is going to be something like our hole is going to be something like that, but what we want is let's just delete all them joins. So what we can do is we can move them out. That's going to go like that. That's going to be the wall. So what we've got is our wall to cut out. But I still need to leave the screw holes, you see. So what I'm going to do, move them in like that, and then we'll use this curve, and what we'll do is we'll draw a curve in there like that. Have I done that right? Yep. I lost track of what I was doing then. Yeah, so if we cut a hole like that, so we need to get it central, so what we'll do is we'll just add some construction lines and we'll extend this stuff on a bit. Actually, I'm just doing it roughly. What I like to do is just, I find it quicker, it's just to put my lines in sometimes. And then join things up. So basically our centre of our hole stays there, but oops, get out there. So I'll just join these up like that and just make sure they're straight. This is going to be yeah, sorry, I was just thinking then. Oh, right, you got, yeah, that'll do. Yeah, sometimes I find it easy to do that. Just so I can make things square and symmetrical, that's all. So what I can do with that point and this point now is just put symmetrical there, and we'll make all these equal each other. Like that, and then you can see now that it'll centralize itself. So if I go like that, look, it all moves central basically. And what I want is basically what we've got is I want to make the wall thickness maybe 3 mil. We can get away with 2 actually. So if we've got 2 on this side and 2 on this side, this dimension is going to be 4 mil less than what it is. So let's just put a dimension in there. And what was that? That was 50. Just reduce that by 4 mil. Yeah, that puts that like that, and then this way goes like that. I mean, what was that? 78. Did I make that 80? So it'll be 76, won't it? Yeah, that looks about right. I think yeah, it looks right. And our holes there. So what we can do is, you know, this can be all sorts of size, whatever size we want, but obviously it needs to fit inside our board underneath. So what we'll do is we'll just make it the same size as that radius there. So let's just go with 3. Actually, I like to put it on top right. Don't ask me why. In fact, actually I don't know whether I need to make these older. Don't know if I need to actually put a constraint on all these actually, because I've put constraints on the others, so they might actually cancel themselves out. But basically what we're going to do is do a 3 mil radius. Oh yes, I needed it. And then what I need to do is actually centralize that, so that there, because I've got 2 mil there, I need another 1 mil, so that's going to be 1 mil. What have I got? There we go. 1 mil. There we go. That's sorted it. So yeah, that's going to be our cutout. So close that. And what we need to do is, if we take a look at the front there, and I'll just show you that our sketch at the moment is on the underside. We want a 2 mil base on that, so what I'll do is I'll lift this sketch up from its attachment, not its position, its attachment, up 2 mil. So we'll just go up 2 mil there, 1, 2. And then what we can do then is just cut everything out. Let's go to the front, and I'll just, you can see where it is there now, can't you? So it pops up here, about here somewhere, there. And so if we click that, and then we do a pocket, and we go through everything, all. Now it's probably going down. Can you see it's going down? We just changed the reversed. So it's actually going from where it is all the way up, and if we look up inside there, we can now see that it's all cut out, ready for us. We've got a 3D model. Okay, let's just bring back our little box lid. That's going to screw straight on top. I like to also add the parts that I'm going to actually fit. So we've got the 4 screws. So let's do that as well. Let's just save this first, because we've done quite a bit of work so far. So our FreeCAD, and what we'll do is create a new folder, and we've got low ohms adapter. Yeah, let's copy that. So we've got a folder, look at ohms, and we'll call this, well, it's already called it. Actually, let's call it that. Let's copy that. Let's just go back up one. Where are we? Yeah, let's just use what I actually called it in the other projects, and then it'll all match up basically. So, but I don't need all these underscores, so we'll go with low ohms adapter in there, low ohms adapter, and I don't need all the underscore. That underscore was for the other thing. It's just one of the conventions. So we've saved that. What I'm going to do now is open up. Over time, when you draw things and you make things, you end up with quite a library. So over time, I've made a library. So if I go to my components, mechanical screws, nuts and bolts and the like, then we've got self-tappers, and I have got my 0.7. Right, we'll use the 1 by 6 mil long, so go in there, open that one, yes, why not, and save it. So I've got my self-tapper there. So I've drawn this previously, and I can always call on it. It's in my library of things, but that's what the screw I'm going to use. So I'll copy that, and I will paste it in here. There we go. So now I can close that one. I've got a copy here, but it's just a basic model. Is that moving it around, multiplying it and things is not. So I need to put that in actually a part. So let's just copy the name of that and go and change that to the same name, but get rid of all the crap. self-tap 1.7 by 6. That can go in there. Get rid of that O1 in at the end. You don't need that. So we've got our self-tap. Right, I need 4 of these, so I am going to just move this up because I like to have my part last. Right, so my part's at the end. This is what I'm actually making. It's the last thing in the tree. So this is going to go invisible. So I'm not going to use this. This is the main part. This. So what I'm going to do is actually make a copy, and I'm going to move this copy up 1 as well. There. So I copy. Because I've made a copy of this one, I can actually now make multiple. So I can say I want 4 of them. So I've now made 4 of those, and these are the links to all 4. So what we'll do is we'll just start by moving 1 around, so which is there. Look at the front, get it up to the right height, so we can see it popping up there. Let's just get that. Oh, there we go, right height. And let's have a look on top now, and we can actually move it into the right position, like so. Are we close there? Yes. There we go. That looks good, doesn't it? That's in there, it's screwed in. So we'll OK that. So what I want to do is I've got the height and everything. I want to put everything in the same place. So if I select the first one, that fills in this fills in all the data for this one, and then what I can do is also select the other 3. And if I alter this data, it will alter all 4. So basically I just move it up 1 and then move it back down 1. What that's done is put all 4 in the same place. So now all I have to do is for that one is go to the top, and I can just, because they're all at the same height and they're all in sort of the same line, when I actually do I move them, I'm only moving them in sort of like one direction. And I do the other one. Apart from this one's going to be moved in 2 directions because it's going over to that corner. And then I move this one, and that moves that all the way across to that corner. And that way it actually shows the holes, and because I've put the screws in, I can see that I've missed everything and that we're all okay. And I also want to check that nothing's fouling underneath. So what we can do with this part, let's rename it. Let's name it as well, box. And also the actual body. So we can have the same name. I'll just put an underscore at the end of this one, so it makes it actually different, but it reads the same, if you get my meaning. Right, so what we can actually do is with this box is make it semi-transparent. So we can toggle, well, make it wireframe, so I'll just toggle that. Actually, it's not that one, it's this one here, the actual box. Let's just toggle that and make it wireframe. And what we can do is we can see that everything is fitting inside how I wanted it, basically. We can check that there's nothing on this PCB fouling where it actually screws down. All these pieces are on the inside of the hole. And we can check this side as well. They're all inside, so I know that's going to fit in there, basically. We've got plenty of room for this battery, and we've got plenty of room for these posts that are coming down, so we know our box is okay. So what I'll do is I'll just put that back as it was. I am just going to make this invisible again for the moment, and I am going to remove my screw. Oh yeah, hey, what? Just hold on a moment. Ah, right. This is why I add stuff, you see. So have I done that? That should have been there, look. Yep, this is why I had stuff. Okay, right, so you can spot and check that things are right. Let's just add that as well, make sure that it wasn't the hole that I did wrong. Oh no, it looks right now, it's sort of even. I must have just put it in the wrong place. Maybe somebody noticed. Right, yes, so yes, and remove my screws. So I'm just going to remove the screws as well. The thing is with the plastic and printing things, I don't like to print sharp corners like this. Well, you can't print sharp corners like this. If you imagine a nozzle on the end of your 3D printer, it's got a 0.4 nozzle on it. That's the thickness of the plastic coming out, and so when you turn round a corner, it's going to be rounded, isn't it? So let's make things rounded. I like to. So what I'm going to do is to put some fillets in. I do like fillets. It increases the file size quite a bit, but it does look like a proper plastic box. I know some boxes might have nice sharp corners in them, but the majority they don't. They have nice little round corners. So what I'm going to do is put a fillet in there. I like to put a 0.6, which is slightly bigger than the 0.4 movement of a filament size. So let's go with a fillet, and we'll put 0.4 in, 0.6 in there. Sometimes I go down to 0.4, but 0.6 is quite nice for that. In fact, what I might do is put a 0.4 on the top. In the bottom, well, I'm just going to go for a 1 mil. There's 1 mil radius, so that looks quite nice there. For the top, now as the holes go all the way through, I like to put holes all the way through. It's a thing. Don't worry about it. You don't have to put them all the way through, but I have in this case. It just means you have to draw them later, and you just cut into them later. But putting them all the way through, it also strengthens the bit of a tube. You end up with like a tube in the side there. If we look at the well, let's just do it this way. You can see that it's going to end up with a tube all the way through, so you're actually strengthening the plastic. So that's why I do it, but I like to put a fillet, and because they're only 0.6 mil diameter holes, that's where the 0.4 goes in. So I'll just select the actual hole itself, just holding Control down while I select them. So I'll select all the 4 holes, and then we'll put another fillet in there, and we'll make this 0.4 this time. So that looks good. And the top, well, I'm going to put a 0.4 on around the top as well, so I'll just select the top and go with a 0.4 there as well. So that makes a nice rounded edges. That way you don't get the crap when you're printing. It does a nice. It doesn't try to do a sharp edge when it prints. It leaves little bits hanging off and dangling. By putting a radius on there when you do your 3D prints, it'll make it a lot smoother. And for the bottom one, well, for the bottom one, I'm going to go with the 0.6. I don't. The bit that actually sits on my bed, I don't do a 1 mil radius. The max I do is 0.6, because that's like if we're doing what you've got to do is think about how what your layer thickness is when you're printing. Normally you'll do, if you want really fine stuff, you'll do maybe a 0.2 mil layer thickness, and that gets some quite fine details. But a simple box like this, I'll do a 0.3 layer thickness. So if I do this 0.6, then the curve is going to be over 2 layers basically. So that's going to be a 0.6 like that. There we go. So now we can look at it. There's our nice little box. 3D print it. So to 3D print that, all we do is we're done here. so I'll just deselect everything. But so this one, for our box, what we do is we export. I've got a button here to export, so you select your box, export, type in box, so that's the name, and it's going to be an STL. So we select STL mesh for 3D printing, and then we press save, and it saves that as an STL file. If we go to our folder where I put them, I'll pause and bring my folder up. There we go. If we look in our file where our model is, this is our FreeCAD model, and then you can see our box, which is the STL box there, and that's what you use. You send to the printer. So I mean, for sending it to the printer, I use Cura, an old version. It's an old printer that I built from a kit. So this is Cura, and so what we can do is just drag that in there, and there's our box, and you just print it out. Oh, it's still loading. There we go. Yeah. So oh, I forgot how you turn it. Yeah, there. So yeah, just print out your box on your 3D printer. So I'll get rid of that. I don't need that up anymore. So there we go, and there's our 3D printed box on our thing. So that's our adapter. We've got our 3 little batteries inside. We've got our jumper. You can leave that off or whatever if you want it on all the time, or you use your button for test, and you use your switch for range, and you put your device across these 2 terminals, and then you attach your meter and read the milliohms, the milliamp, no, the millivolts. Yeah, I'll get it right. Yeah, you read the millivolts across here when your device under test is on there. You read the millivolt. You connect your meter to this as well, and you read your millivolts, and your millivolts, depending what range you're on, you sort of multiply by 10 or multiply by 100, or is it divide? No, multiply, divide this. You divide. If you're on if you're on 10 millivolts, you divide by 100. Sorry, let me start again. If the range is on 10 milliamps, you stick your voltmeter on and read the millivolts. You divide the millivolts by 100, and that gives you your resistance. If you're on the 10, if you're on the 100 milliamp range, you stick your meter on, measure your millivolts, and you divide your millivolts by 10, and that gives you your resistance. I'll write it down somewhere, but anyway, I hope you enjoyed that. It was just a simple box, and just how why I actually go to the effort of drawing everything out, and why doing so enables you to make sure that everything is going to fit. Oh yeah, put the screws back. There's the screws as well. Yes, so yeah, if you made it this far, thanks for watching, and remember, if I do a long video, oh, I've made it under an hour again. That's good. Yeah, just under an hour. So let's try and achieve that for the next one. Okay, thanks for watching, guys. Catch you later.